Okay, graph the solution to a linear inequality. So we have 6x minus 3y less than or equal to 9. To graph these inequalities, you always have to start off as if it were an equal sign. So imagine if that were an equal sign, it would just say 6x minus 3y equals 9. The way you would graph that, same as ever. Your goal is to search for the y equals mx plus b. So let's go ahead and remind ourselves of that. Our goal is to search for mx plus b. Only way you can do that is to get y by itself. So that's what we're going to do. Try to isolate y. I'm going to go ahead and minus 6x from both sides of the equation. Okay, minus 6x from both sides of the equation. And then that will give us then negative 3y is less than or equal to negative 6x. And again, that was a positive 9, so it stays a positive 9. And then we're just still trying to isolate our y. So I'm going to divide by negative 3. Just don't forget, when you divide one side of the equation by something, you must divide everything. So the negative 6 and the positive 9, all things have to be divided by the negative 3. It's just mathematically fair that way. Alright, and then we can go on and see what cancels. Now the negative 3 cancels, so we got y by itself, just what we wanted. However, every time you divide by a negative number and you have an inequality, so let's look back at that inequality, that's what we're dealing with, we have to be careful. You divide by a negative, the inequality changes directions. So it started off as a less than or equal to, and now becomes a greater than or equal to. Again, that's only if you divide or multiply by a negative number. And then we can continue on with our numbers. So negative 6 divided by negative 3 turns into a positive 2x. Positive 9 divided by negative 3 turns into a negative 3. All right, so now we've gotten the y greater than or equal to 2x minus 3. So this is what we have as our y equals mx plus b. Let's go ahead and graph that. First of all, we do have that y is greater than or equal to, so that is certainly going to be a solid line. If it were a strictly greater than, it would be a dotted line. But let's go ahead and create our solid line. So our b is the y-intercept. So negative 3, whoops, sorry about that. There we go. Negative 3 is our y-intercept, so let's draw that y-intercept there. And then we have to talk about that slope. So if you guys go back and remember, let me write that in a different color. 2 was our slope because we have that y equals mx plus b. It's easiest if you think of that as 2 over 1 to be your slope, because then you can do your rise over run. So that's what we've got there. So our rise over run, we're going to start from our y-intercept, go up 2 over 1, and that's where your dot starts. You start from the y-intercept, go up 2 over 1, that's your second dot. And that's how you connect your dots. Okay, so we're going to connect this as a solid line because of this inequality had an equal to underneath. It was greater than or equal to. I'm going to go in both directions just so that looks fair. All right, and then we can talk about our test point. So I'm going to go over to a new page so we can see our test point. Go back and look at what we have. We have y is greater than or equal to 2x minus 3. When you look at your graph, you're going to pick a test point. So I'm going to pick my test point. Okay, I'm going to pick the origin. Call that T for a test point, simply because if it's not on the line, the origin is the easiest one to pick. So we can just plug that in. So we can plug in our 0, 0. I will get 0 greater than or equal to 2 times 0 minus 3. So that's going to become 0 greater than or equal to negative 3. Is this true or false? Is 0 greater than negative 3? Of course it is. So that's true. Go back to your shading. Always shade towards the truth, away from the false. Always towards the truth, away from the false. So I'm going to shade here towards the truth. So if you can see that there in the background, that is our answer, just like that. Solid line, shade towards the truth. Okay, maybe I should shade that in blue so it's the same. Ta-da!